Right, welcome back, Science 7. Without further ado, let's start our another lesson on Unit C. We are at Chapter 2, which is a little bit more chemistry-like section of the heat energy. Before we begin, I want you to start with Science Log Activity number 7, which is about analyzing about what you see inside of this scenario. Determine if the given picture represent any type of physical change, and you need to explain. And the question that I put is chocolate is melted in a hot fondue pot. I want you to pause this video and write down your explanation. All right, once you guys did that, here's my answer. Let me share mine. Chocolate melted in a hot fondue pot. I'm going to draw my example first. First thing first, we have pot and we have chocolate. And chocolate is a solid. But meanwhile, there is a heat source over here. So I'm going to go through what is happening in this situation specifically. So first thing first, ladies and gentlemen, let's go with our step-by-step heat tap. Let's talk about that. First thing first, we have heat source. Heat source is basically fire under the fondue pot. And when it comes to its path, heat is absorbed by the pot, which is metal, and heated metal transfers heat energy to the chocolate, which is solid. And after that, solid chocolate absorbs heat energy. And because of that process, and this is what I'm going to highlight, ladies and gentlemen, because that's the main part, chocolate melted. And when I talk about melting chocolate, that is a fancy way of referring that solid chocolate turning into liquid. So it is an evidence that there is a physical change occurring, and physical change is solid turning into liquid. All right, Science 7, let's do something very similar. This is now Science Log Activity number 8. I want you to do the same process except the example change it. Banana is rotten and it become mushy. I want you to look at this and connect with our previous idea, and let's write down if this is an evidence of physical change or not. Pause this video, work on it, and reactivate. All right, once you did your writing, please compare with mine. So we are talking about the original banana, which is located over here, that turning into slowly as a rotten banana. And our job is basically finding this out. Is this some kind of physical change or not? In this case, I like to say, no, it is not a physical change. There is simple evidence. When it comes to physical change, you need to look at two different parts: solid turning into liquid, or other way around. Is that what's happening? Or liquid turning into gas, and other way around. If you look at rotten banana, I know it's nasty and the mass is probably reduced because some of them evaporate away. I know it's turning into little juice and dripping, but that's a process of change of chemical structure. If you look at the physical itself, it's solid just turning into mushy solid. I know it's mushy. That means solid become a little weakened by the process of rotting process or decomposition. But one thing that you need to understand is solid is still solid. So this is not an example of, how can I say, physical change. Have that in your mind. So physical change and chemical change, we need to understand those two differences. I know you have a table, so I want you to feel this one by one. When people mention about physical change, that specifically refer about matters only changes physical arrangement. So that means H2O structure rearrange to become solid, liquid, or gas. Physical change does not alter, which means does not change, chemical properties of matter. So that means if I simply putting in solid butter and liquid butter, they are exact same type of chemical. And it tastes exact same too, if you think about it. Chemical change, on the other hand, ladies and gentlemen, chemical reaction must occur. And reaction is you're combining something or you're breaking things apart from one chemical to produce others. Physical state does not always change. Like, for example, if I make acid and base, I can create another chemical that is still in aqueous solution, something like that. Liquid also produce liquid, or gas can turn it into different type of gas. And a good example is nitrogen gas and oxygen gas can turning into nitrogen dioxide gas. That's a good example, even though it's a little advanced one. You will learn in grade 9 and 10. A new product must be formed, and this new product, I want you to understand that it is completely different type of chemical. So I want you to look at these example. These are the example of physical change. For instance, crushing a can that's solid turning into some kind of solid. So there's no specific physical change that happening between different forms, but I want you to understand that it's a same chemical property. I believe can is aluminum mostly. Melting ice cube, solid turning into liquid. Boiling water is liquid turning into gas. And mixing sand with water, this is, well, still water. Soak it into sand, so it is a still same type. Breaking glass is the one that, how can I say, solid turning into just smaller solid. Dissolving sugar in water, this is a little tricky one. Solid turning into, we call it aqueous solution, AQ. Shredding paper, same type of paper, same type of wood. Mixing green and red marble, same marble. And dry ice turning into gas. Sublimation is actually, this is a tricky one. Solid turning into, or other way around, gas. So basically, what causes physical change is physical damage or transfer of heat energy. That's it. Talking about that, I forgot to put one thing in previous one. Can you guys all go back to this banana situation? I forgot to put one thing. Banana rotting is more about chemical change. And I only emphasize physical change that turning into solid, liquid, liquid gas. Come to think of it, I forgot to mention about that. Sorry. When it comes to banana, solid to solid, if you, for example, cut this banana in half, it's a physical change. However, if you look at the reactive part, like this dark part over here, that banana solid is different than this yellow part of banana. That's what I wanted to point that out because this is completely new material by the chemical reaction, in this case by bacteria, and that's something that I wanted to point that out at this point. Sorry about that, there's a little skipping going on. Now, chemical change on the other hand, it is various type of reaction like rusting, burning, cooking. Metabolism is burning the energy too, actually. Well, absorbing it too. Baking, electroplating, that's a electrical energy, and it's called electrochemistry, which you guys will see more in grade 9. Rotting, there you go. And mixing the chemical, firework, which is combustion, very similar. And chemical energy, chemical battery, which is the reaction between solid and acids, those kind of things. So chemical change must involve turning reactants into product. That means if I combine A and B together, you have to make something completely different like C and D. And these guys are not equal together at all. And sometimes we use particle model of matter because it helps us to understand different physical states. And I believe for today's, oh, let me just quickly, yeah, to go over the basic one. So let's power through. This will be my last slides today. It is important to develop some model because if something is too small to observe, like water molecule, we generally build a physical model, sometimes construct, sometimes draw, for scientists and students to understand things a little better. When you make this model, there are 4 rules when it comes to physical model. All matters are made up of extremely tiny particles. Tiny particles are always moving and colliding. Adding heat makes particle move faster, and there are enough space between. That is today's lesson.